Hello and welcome to the Data Idols Summer School. I'm David Lachlan. I'm the founder at Data Idols. I'm a data engineer by heart. I did that for a number of years before starting Data Idols, which is a data-focused recruitment business. I've mentioned this before. I'll mention it again. I'm probably the only data engineer that thinks it's a good idea to start a recruitment business. But I did it, and it turns out it's really good fun, and a lot of people need our support, which is always nice. In terms of the summer school, it's an idea we've had for quite a while. Our aim is to provide a free resource that people can access from anywhere in the world to start to build their knowledge within the data space. It covers introduction to a number of the key technologies, Python, R, SQL, Excel, builds on from there, covers some of the core mathematical concepts that are very relevant within the data world, before talking about machine learning, going into engineering, data ops, ML ops, getting stuff into production, and finishes up with some content on visualization. In terms of how people can access the summer school, we're going to be running it live, so people can go through it in real time. We have a Slack community where people can can work with others and communicate with others while they're doing the course. It will also be available on demand from September onwards. How can we make it possible? As you can see on the slide in front of you, we've depended on the support of a number of forward-thinking companies who have given up their time, given up their knowledge to provide content for the summer school. We definitely couldn't have done it without all of these companies and all of the speakers that are part of the summer school. We have 37 in total. And we worked out it's probably about 400 hours worth of work to coordinate it all together. Jess and Amy have worked really hard behind the scenes, getting all of the content recorded and edited. And obviously the speakers have given up their time to record their content. So really hope you enjoy it. In terms of today's session, really pleased to be joined by Rob Mastrodomenico. He's from Global Sports Statistics and will be presenting a session on basic Python libraries for data science. Hope you enjoy.
Welcome to this webinar on basic libraries for data science. My name's Dr. Rob Mastrodomenico, and today we're going to be talking about basic libraries for data science using Python. So let's get started. So the overview of the presentation today, this is what we're going to cover. We're going to talk a little bit about me, so you get to know a bit about my experiences, why I should be allowed to talk about this. What do we mean by data science? Because I think the concept's quite big, and I kind of want to focus people down on what we're going to consider data science to be for the purposes of this presentation. I'm then going to talk a bit about why Python. You've got lots of options when you want to kind of work in the data science field, why I think Python's a good choice. And then we're going to go through the basic libraries that I think you should be looking at if you're looking to get into data science, what we can do with them and where next. Now, the good thing about this is I'm not going to show you any code. We're not going to go through code examples. For people who are complete novices to programming and are kind of looking at this as a stepping off point to kind of get them into working with data science, this is the right kind of level. For any of you who do have experience in data science and maybe haven't seen Python before, this will hopefully give you a few pointers. And for those of you who have a bit of experience in Python, this might point you in the direction of a few libraries that you can use, and also why you should use them, and kind of hopefully give everyone a bit of a bigger picture. But let's talk a bit about me. So my name's Dr. Rob Mastrodomenico, as I said earlier. I have a PhD in applied statistics and a career of 15 years in data science. And I've kind of, my speciality, I suppose, is the application of data science to sports. I've spent a career working on different applications to predictive modeling of sports, in a variety of sports in a variety of ways. I've run my own consultancy company. I've done roles as CTOs in various companies. And so from kind of data science tech point of view, I have a decent amount of experience. And during that, I've been a Python programmer for 10 years. You can obviously, if you can look back, you can see that doesn't apply to my whole career. I have experience of programming in other languages, which I think is quite important when I'm going to talk to you about Python and why you should use Python. I started off programming in R. I've used other languages, C++. I'm pretty proficient in web development, and I've used various databases and other languages around that. And I've really stuck with Python. I kind of made a decision 5 years into my career after essentially using Python for a small pet project that I thought this was a great language. We're going to talk a bit more about Python later, and I'll go into some more details to why I think Python's really useful. I'm also the author of the upcoming The Python book. So hopefully that gives you a little bit of confidence that I do know what I'm talking about and that you can kind of trust what I'm saying. But my kind of experience in data science with Python is fairly large and hopefully enough to kind of give you confidence of what we're going to cover today. So what do we mean by data science? As you can kind of see from my background, I'm applied statistics. And so in a kind of parallel multiverse, I might be classed as a statistician or a quant or something different. But these days, I'm kind of known as a data scientist. And I think that's more so because of my kind of love of tech and the kind of application in terms of statistics, modeling, machine learning, AI, all those disciplines, that make up data science. It's a huge kind of area when you kind of look at it, and it encompasses lots and lots of different roles. And that could be something from as simple as data analysis to complicated AI and machine learning models. And so when we're kind of talking about data science and the basic libraries, it's really key that we understand what those are and where we're looking to kind of essentially place ourselves. And I'm assuming the individuals who are listening or the point of this is to really go for that kind of 101 basics. And I'm a big believer in like really good fundamentals will make you a good programmer. Alongside writing the Python book that I have, I've taught Python for many years. And so I'm a big believer that if you understand the fundamentals well enough, you can kind of build on that quite easily and develop lots of areas around the language. And so I'm really going to talk from the kind of fundamentals I think you need when you're looking at data science. And those building blocks are going to allow you to go off and do data analysis. And then if you want to do some machine learning or use these new packages, having those base skills are going to really accelerate your development through it. And I always think in terms of programming languages, not too dissimilar to learning a language, in that you have to get your fundamentals right before you can kind of jump off and start conversing in it. And it's the same with kind of programming. If you get your fundamentals right, then it's much easier for you to go and move on to something, pick up something new. From myself, from personal experience, it's really easy now for me when something new comes out for me to just get involved, try it, learn by doing, because my fundamentals are quite strong. So I can understand a lot of the basics that go into it, which then makes learning something new much easier. But this is what we're going to look at today when we kind of talk about the libraries that you can use. Now, why Python? Well, I would say, why not? I'm, for full transparency, I love Python. It is my primary language, as I've said. I'm probably biased, but I think I'm in a position where I can kind of talk about it in relation to other languages and why I like it, and why I think it's good. So I think the first kind of thing is it's simple to learn and it's got really easy syntax. And this is one of the reasons why I like teaching it, because I can get somebody who's never programmed before and in a couple of days get them to a place where they're programming, because the way Python's written very much kind of matches onto that kind of pseudocode thought where you would plan a bit of code and you would look to write it as a kind of as logic. And when you write that then into Python, it very much mimics that. So it makes the whole thing much easier for kind of new programmers to get into. But for somebody experienced as me, it also is very easy for me to just kind of write something. It's not compiled. so I can kind of script in it. That's a really important thing, I think, with Python. In your development time is reduced massively, and I can do lots and lots of things. It's got a large community of users, which I think is really important. And I think when you're looking at kind of programs to use, things to do, that community is important, because you're going to have problems, you're going to get stuck, you're going to want to see things develop further. And there are packages I've used even in Python and other languages I've tried where the community is not so big and you can get stuck and you don't know where to go. But because Python's community is vast, you see lots of development, lots of help. Stack Overflows, always very good to use for any Python problem. And alongside that, you get a huge collection of packages. So I kind of see, for my use in my day-to-day work, Python's the glue that kind of puts everything together. I don't have to use other languages to do things. I don't have to kind of fudge them together to make them work. Python not only has a huge collection of languages, whether you want to do web development, APIs, machine learning, AI, statistical modeling, web parsing, data analysis. You think of it, Python will have you covered, because it's a massive library. It can be written in a variety of different ways, and it also plays well with others, and that's key, because Python isn't perfect. I wouldn't say it's the fastest language ever, and there might be times when you need speed, and so you can leverage other languages or other things to help you do that. And so it plays well with others in that regards. It also is very well accepted into kind of common web hosting, anybody who's used AWS or Google Cloud, it plays well with that. I'm a big AWS user, and Python is a really easy thing to get on there if you're developing in it. And so I think that helps as well, that it's been used in those areas. So I think it's a really strong choice. There are other choices, of course, and this talk isn't there to kind of mention those, but you might think about other languages like R, which potentially is good for data science, but my preference is Python. So I'm going to talk to you about Python, and it's up to you as the individual if you want to look at what's out there. And I'm an R user as well. I've used R for the first 5 years of my career, and I think it's very good. But I just think Python's a little bit better, maybe a lot better if I'm being honest. So before we get into those packages that we want to use, I want to kind of give an honorable mention to kind of some of the base of Python. And this is not an intro 101 of what Python is, but when you're working with data science, a good appreciation of some of the fundamental kind of containers in it is really good, because what that means is if you can use these, you can do quite a lot with it. So for example, when I teach Python, these things, lists, tuples, dictionaries, sets, are kind of key to it. I want people to be able to understand in the kind of pure Python language what these do. And for those of you who are new to Python, what that would mean is Python is essentially a language which has a core to it and lots of packages that people will build to do other things. And so we're going to look at 4 different third-party packages which work with Python and are really good, but Python has its own kind of data types, and they can be used with them. And lists, tuples, dictionaries, and sets are kind of key to understanding how Python works. And a lot of these map very nicely to some of the packages we're going to talk about. So I think there's, especially today, it's very easy just to find a package and jump into it and just get started working on that package. I think it's quite good to have an appreciation of the basics, as I've said a couple of times already. So looking at kind of lists, tuples, dictionaries, sets, how they work, what methods they have, that does apply well when you're looking at some of the things we're going to look at next, because they'll be built upon these. So, and you can do a lot with the basic types in Python. I remember we're going to talk about Pandas, which is a data analysis package. When I first started coding, we didn't have Pandas, it hadn't been released. So I had to use things like this to essentially build some of the concepts that Pandas did much better than I did. And they work fine. And when you get into it, you can kind of see they're built on a lot of these concepts here are key parts to that. So I think anybody who's kind of looking to get into it really should have a look at some of the basics of Python before even moving on to the packages that we're going to cover. So these are them. These are the basic libraries that we're going to look at. So Numpy, Pandas, Matplotlib, and Seaborne. And so I've kept these fairly data and visualization centric, because for a kind of point of view of basic data science skills, I think there's that kind of ability to use data in a way that's going to help you achieve what you want. And so these packages, they not only kind of in their own way have lots of, allow you to kind of do things, they also allow you to do things and move on to something else. So if you have another aim in mind, you may need some of these packages to help you do that. So if you're going to use a machine learning model, there might be some, there could be multiple of these that you'll want to use. For example, Pandas, Numpy for data manipulation or setting up your data in the right way, and Matplotlib and Seaborne, which are plotting packages to produce results on the other side of it. And so these are what I consider the kind of core concepts. And these are the things that I would teach or look to kind of tell people to use, so that they can kind of essentially have the skills to work well within the data science, sector. So let's start with Numpy. So Numpy, and this is from the website, it's the fundamental package for scientific computing with Python. So Numpy has been around for a while, and it's a really kind of important package because it was built to give speeds comparable to C and Fortran. So for the novice programmers who maybe aren't so familiar, the kind of languages like C and Fortran are really fast. So you can do things very, very quickly in them. And one of the kind of downsides to Python is, especially when it comes to concepts like looping or iterating across your data, is Python can be quite slow. And that's always something that people kind of down talk Python about. And when compared to some other languages, that can be a problem. And Numpy was kind of built to solve that kind of problem by essentially building itself on top of C and giving itself speeds that are really higher. It's a kind of it's like Python's version of languages like it's kind of like the mathematical kind of side of Python, in terms of its main concept is the array. So an array is a bit like a list. Essentially, it's an object to contain different values within it. And the array and the way it's written, the way you can operate on it, is you can get kind of very, very big speed increases in terms of operations that you want to do by using it. And it supports a lot of vector matrix operations, very mathematical in the way that it works, in terms of you can kind of write a lot of kind of more mathy type things that you wouldn't be able to necessarily using some of the standard Python types. If we compare a list to an array, a lot of the operations you could like do on a list, or on array, you can't do on a list, because this is built to kind of perform some of the more kind of traditional mathematical operations, the way you would add two arrays together or multiply them or subtract, or a lot of that kind of stands up to what you might be taught in your kind of, if you did a data science degree or you were looking at kind of matrix vector operations. So it's a really kind of strong contender, especially if you're looking to do vectorized computing. It supports things like parallel computing, GPU. It's really good, and it kind of falls into a lot of what other packages are built on because of that speed. Because when if people are trying to build AI machine learning models, you need them to run within a time frame that's going to be realistic for what you want. So the use of Numpy and what it brings to the kind of Python community is big. If you go to the website, there'll be examples of kind of what you can do with it, examples of how it's been used. And you'll find other packages where they'll be looking at having Numpy arrays. Set your data up into arrays, put them in, because that's how they know they can kind of get fast increases of speed when they're looking to perform those calculations. So it's a really kind of key one to learn and understand how it works. And so I kind of have this as not necessarily the first one to use, but because this is the kind of the oldest or one of the older of the packages, it's a really useful one to use. And it kind of links back well to that kind of machine learning, AI modeling point of view, where you might need some of these more mathematical operations. Alongside that, there are a lot of other kind of operators and things that you can apply to these arrays. There's a lot kind of under the hood that you can do. So, but beyond that kind of main concept of the array, there's a whole kind of other world that lives within that. And so this would be one of the ones that I would first look to consider. Now, the second is Pandas, and Pandas was a real kind of game changer for me. So if I kind of go back to when I first started using Python, I was moving from R, and in R, there was the kind of concept of a data frame, and the data frame was really important. So if we kind of consider some kind of square rectangular data, and you want to work on it in a kind of column row, and you want to perform fairly complicated analysis, you know, really kind of filtering that data set down or splicing, sub-selecting, that was really prevalent in R. And it made it like a really strong language to use. You could kind of avoid things like looping, and you could do complicated operations on a big set of data in a speed that was good. When I first came to Python, as I think I said earlier, we didn't have this. So Pandas coming out was a game changer. Essentially, it took a lot of the concept of a data frame that was probably borrowed from R, and also a series, which is a kind of extension of an array, a list, a dictionary, kind of all rolled up into one. And it made these, it's kind of essentially what I would call the feature objects of Pandas. And what Pandas is, it does a data analysis. It allows you to do data analysis. And it's a kind of very, very powerful and you know, strong language used again in a lot of places within Python. So there'll be a lot of other packages that we like Pandas as a data, will allow Panda data frames as inputs or various things from that. But Pandas in itself is a kind of really huge area that you can kind of cover. So if we can consider operating on kind of either one-dimensional or data frames, which are kind of multi-column row data, we can delve into things like multi-index. You know, we can give our kind of data frames a lot of different things associated with them. So build up kind of data collections which look a lot more like we would expect in the real world. We can kind of move beyond what would necessarily be a kind of, if we think in terms of spreadsheets, an Excel sheet. We also have the ability to do some pretty complicated analysis. So, and one of the great features of Pandas is its ability to kind of do database style joins, merges in a way that's pretty quick and very, you know, very easy to do and very fast. So you could have two sets of data that you can join on a common key. Historically, you may put that in a database and look to kind of normalize it, get it in a position where you can kind of join those together. Pandas allows you to kind of do that essentially directly from the raw data, and it's really powerful. It's got a lot of kind of things that you might expect if you were moving from, say, if you work with spreadsheets and you do things like groups or pivot tables, you can do a lot of that within Pandas, and it's easy to do, it's fast, and because you're doing it within a coded environment, it's repeatable. And I think that's a kind of a big point to all of this, even if you're kind of working with data out, not programming at the moment. One of my big kind of things of programming as a whole is the repeatability and the fact you can write something and you can test it again and again and fix bugs and get it checked. It also has kind of lots of extra features. And, you know, like it can read in multiple different data types. So, you know, Excel, CSV, JSON, it can write back to those types. It can interface well with databases. So if you have a database that you use, you can essentially use Pandas to read data directly out of that into a data frame. Really powerful, really cool stuff. And you know, we could do a whole hour on just some of the features of Pandas. It's good at kind of missing data. It deals with that. It has a lot of kind of standard functions that you might expect for data analysis. So one of the kind of common things I always tell people when they're working with Python is if there's something you want to do and you feel like it should exist, check that it doesn't exist. And Pandas is a great example of that. So you've got a data frame, you've got a collection of data. You maybe for a column, you want to work out the variance, the standard deviation, the mean, the mode, the interquartile range. You might can think that you have to write that code yourself. Well, Pandas has you covered with that and more. It has lots and lots of kind of out the box methods that you can just apply not only to columns, but to multiple columns, to a whole set of data. And it's smart enough to kind of understand where you can't do it. So one of the nice things with Pandas is if, say, there's a great method called describe. So if you have a data set and you describe on it, it will give you out a number of statistics. But what it also knows is that not every column can have every type of statistic. So if your column is of type string and you can't then work out the mean of that, it won't. And it won't throw errors. And it's pretty clever. One of its big things as well is that dealing with missing data and how it knows how to kind of deal with it when you're maybe doing processing. So it's really cool, and it plays well with others. And this is going to be a kind of common theme as we kind of go through this talk, is that playing well with others, because what you really want in a kind of library is something that allows you to then use it elsewhere. Because if you're going to base a lot of what you do around a package, then you don't want to then have to learn another package just to do something else. And the kind of, the scientific libraries really within Python, a lot of it will be based on Numpy and Pandas. So a really good understanding of that will not only allow you to be able to do, really good data analysis very quickly, but also allow you to kind of expand into other areas. So, you're not pigeonholing yourself by using this. In fact, these are the kind of building blocks that people kind of use when they're building other packages. And as well, these are all linked to, say, the common data types within Python. So, you can build up data frames using NumPy arrays, lists, dictionaries, tuples. They all kind of link back. And I would kind of recommend taking the time to understanding how these work before you dive into it, because you could just essentially go onto the Pandas website and start coding straight away. It's that well written and that straightforward. But I think a little bit of time taken to understand how this works is really going to help when it comes to how you work with this and what you can do. And really, there is lots you can do with it. But those are the kind of ones that deal with the data side of things. The other side of that is your visualizations, which again, as a data scientist, is really key. If we kind of, not just to go back to Pandas, one of the kind of key things when you're dealing with data is how you get something out of that that's usable. Now, Pandas is pretty good because it has a lot of export functions. So you can export data to an Excel sheet, a CSV. If you're familiar with things like LaTeX, you could put a table into a LaTeX format, and then you can use that in a report. But one of the kind of better things that you really would like is some kind of plotting functionality. And Matplotlib is the kind of granddaddy of them all. It's the kind of key one that you would use within Python. And it's something that you should really, again, take the time to understand. Now, Matplotlib, it's got a lot you can do with it. So it's very customizable in that you can kind of build yourself your own plots. You're not constrained to, I've got, if we think of, again, going back to a spreadsheet, you run the wizard in Excel to create a plot. You're kind of constrained by the plots they offer. In Matplotlib, you can kind of really build yourself up a customized plot or a plot, and then have a lot of control on what that's going to look like, what you add to it, how all that's going to be. And I think that's kind of important as you work with data that's kind of not standard, or you're trying to get across a point that doesn't necessarily fit into a standard graph. And so the understanding of how Matplotlib works is crucial. And Matplotlib, as it's kind of being that key package, links to lots of other packages. So again, going back to Pandas, in Pandas, as part of data frames, we have the ability to produce plots. And knowing how Matplotlib works will help you be able to do that, export them, work with them in a way that's going to allow you to be more productive. There's probably a kind of argument that Matplotlib can be maybe a slightly complicated package. And it's not in always really straightforward how everything works, but once you get into it, it's got so much control and so much you can do. If you can think of what you want to do, Matplotlib will most likely allow you to do it. And so there's lots and lots to it. It's a big package, and you can kind of produce lots of graphs from it. So it's something that you should consider as part of a kind of key thing that you need to know. So this is kind of one of the bigger ones, and this, I'm going to kind of continue on with this with the next one, which is Seaborne, which I think is one of the kind of best. It's my go-to package when I want to produce plots on top of Matplotlib. So I use the two together, and the reason you would do that is because they integrate well, but also you need that level of control that Matplotlib would offer. But Seaborne is a library for making statistical graphics in Python. Again, that's the tagline from the website, and it's a really kind of good package. I'll give the other kind of tagline that's in here. It's high quality charts focusing on the user understanding the data. And what that means is they want the users to actually use it and not worry about how to build a plot, which could be an argument put back at something like Matplotlib, where you've got an idea for a plot and then you spend a lot of time learning how to kind of build that plot. Seaborne, for somebody who's maybe needs to produce something, is quite good because you have a lot of plot types, of which can be customizable, but it gives you a better idea of what you want. And I think from the Seaborne examples, there's lots that kind of it meets, I would say, most of what you would need from kind of standard plotting, especially kind of plotting with data. Obviously, if you're going to move into things like visualizations that move through time and space, which you can do with Python, you're going to have to go on to something else. But these are the basics, and Seaborne integrates really well with Pandas. So one of the really good things is it plays really nicely with data frames. And I think when you kind of build up those skills where you're working on Pandas for your data analysis, maybe a bit of Numpy, Matplotlib, Seaborne, you kind of get into this routine of a really kind of strict way that you work, which should become fairly natural because they all play quite nicely together. One of the cool things with Seaborne is because it wants you to understand the data, its way it plots is very data focused. So you can kind of do a lot of things around how you want your plot to be, as the point of I now want this variable to be slightly different. You can just interchange. And because a lot of their plots, they have lots of different types, you will most likely find what you want from there. I find it really easy to use and really flexible. I've kind of essentially moved all my plotting, and I moved it all from kind of Matplotlib, where I was just creating it myself. I do everything now using Seaborne because I just think it looks great and it's quick. And I think, again, going back to why Python is easy to use and flexible. And that's one of the things with Seaborne and Pandas and the other languages, other packages that we've covered. You need it to be quick because you ideally, you want to be as productive as possible. The less time you can spend coding and the more time you can spend exploring your data and working with it, it's just going to make you much more productive. And Python kind of supports that because it's easy to use. And these packages kind of fit alongside that. Now, there are lots of other plotting packages within Python, and they can do various things, and they're all good. The reason I've kind of chosen Seaborne on top of Matplotlib is I think it's the most kind of developed of the packages. And I've used the other packages and they're good. There's other stuff. If you do want to plot with your data, you can even do it, as we've said, with Pandas. So you can kind of go back and say, direct from your data frame, give me a bar chart of my data, or a histogram, or a line chart. And that's quite good for kind of exploratory analysis. I think when you get beyond that to produce kind of plots that you might want to use in a report or a presentation, I think Seaborne is my kind of choice. And for any of my kind of consultancy work, if people want plots, and I will be going to using Seaborne because I think that's really good. I might use something like Pandas or Matplotlib just for some exploratory stuff really quick, but this Seaborne produces some really, I think, production kind of quality style charts. And all of these support export to different formats for however you want to use it. and you can kind of leverage elements in there to kind of get it as you want it to be. I'd definitely recommend checking that out. The kind of documentation on it's quite big because there's lots of plot examples. So take your time to kind of at least familiarize yourself with the different plot types that are there. There are still many that Seaborne offer that I've never used, just because I've never had the data in a kind of format to, you know, use that type of plot. So I always think that's positive when there's more plots on there than you need or than you want to use, but it's got all the kind of fundamentals, you know, down. And because it's based on kind of statistical graphics, it has an element of kind of statistics about it in terms of, you know, distributions, confidence intervals, things that you would kind of want out the box. You don't want to have to, you know, do yourself. For example, you might want a confidence interval around on a line chart, you know, to see the kind of variance around your values. You can do that kind of thing in Seaborne out the box. In other languages, you'd have to, you know, if we're doing it in Matplotlib, we'd have to calculate those values and plot through, you know, the relevant lines that we need. And I think that kind of way of working and thinking and giving you those options just makes it a really strong choice of kind of part of that. So what can we do with these? So we've got 4 libraries and some of the basics in Python. So the way I kind of think about this is these become your kind of fundamental tools for dealing with data. Now, as a Python programmer, I think, you know, you need to consider Python is like your toolbox. That's the toolbox you've chosen. But when you start, it's pretty empty. There's not a lot of things in it. And as you learn these, you know, these libraries, these packages, you start putting extra stuff in it. So when you come with a problem, you can be like, I can just go to that one and I can solve it with this tool. And I think it's a nice way to think about it, because these kind of 4 become fundamental tools that you're going to use a lot. But, you know, if we go back to the analogy of building, you wouldn't always just use one tool to do everything. So you might need to use a couple of tools to kind of solve a problem. And it's the same with Python. So I think it's very much your start and your end of a lot of your problems, in that most problems start with having some data and they usually end with some kind of either export or visualization of those results or that data that you've had. So that's really key in terms of you can achieve it with these 4. But the things that you'd be looking to do, and if we kind of consider a standard maybe pipeline of development, is you get some data in whatever format. You might need to do some manipulation, aggregation, even some, you know, transformation around it to get it into a format that you need. That may or may not include some visualization initially to understand your data. And so you can do that with the packages that we've covered already. And once you've kind of got that into a format that's usable, suitable, clean, then you can go on to use some other kind of package for what you want. So that might be as simple as just exporting it to a spreadsheet for somebody to look at. You might, like, you know, it might be a manipulation of data into a format and an aggregation so somebody else can look at the results. It might be that data now is suitable to go into a database. It might be this is a pipeline into a machine learning model. It could be this is then going to go to an API or somewhere else where it's going to be used in a different format. It could be any of that. And so, you know, that kind of first stage is there. If we kind of then think about that route of modeling, and we kind of continue along what we initially discussed as data science, then we may end up with some predictive model or some kind of machine learning model around the data that we've got. And then we might even go back to kind of the visualization to visualize the results, to present it that way. There may be results from there that we need to export and put into a report or do something around that. So what you've kind of got here is a lot of the glue that's kind of allows you to stick to other aspects of Python and solve your problems. For me personally, when I'm writing, I'd be very surprised if I write any bit of code where the first line isn't from import pandas as PD or import numpy as MP. And that's your kind of the way you import packages in for those who aren't familiar. But I would say most of my code will have that in, because even if it's something like, you know, scraping a website and getting back some data and manipulating that data, a lot of the time I'll find it easier to do it in a pandas data frame than I will from lists and string manipulation, just because it's very powerful. It has a lot that you can do with it. And so, I'll have a lot of that will be in there. And so it's just a real kind of key part to what I do as a Python programmer. And I think for you guys as kind of data scientists, this is a kind of key concept as well. So I would say, this is something that you need to consider and learn. Probably one of the bigger things, it's very easy just to go out and start coding. There's so many tutorials out there. There's so much content available to just say, yeah, just dive in. And I'm a big believer of learning by doing. But I'm also a kind of bigger believer of making sure you've got good fundamentals when that kind of moves beyond that. I think for a lot of programmers, there's that kind of using something just to essentially figure it out, understand how it works, the exploratory stage. I think that's great. I think, people should be getting hands-on as quickly as possible to kind of understand what they're working with. But then if it's something you're going to consider to use more kind of day to day, and you get around that, I think understanding how it works, understanding the fundamentals behind it, it's just going to make you much more efficient, because you want a program and be able to write code like it's second nature. You don't want to always have to refer to, documentation or how do I do that? And I think understanding the fundamentals and what you can do will set you up really well to help you do what you need to do. So where next? So the libraries play well with others. And so they will plug into a lot of the machine learning, statistical, predictive kind of packages out there. So it would be scikit-learn, TensorFlow, SciPy, things like that will play very nicely with these. And the resulting kind of output from those will play nicely with the visualizations. And so regardless of your kind of area of expertise, this is your kind of where you start, and this will help you move to where you want to be. But in the data science world, it's a kind of key part. So, keep in mind those packages and how they work with others. And also, if there's something you want to do, maybe see which package you might need to use to learn it. Not all, machine learning algorithms are going to need Pandas as an input. They might all be based around Numpy arrays. So therefore, that might be your starting point. You don't necessarily need everything right away, and it's the kind of the right tool for the right task for you. But what we've covered, I think, gives you a good grounding across pretty much everything that you're going to need in terms of working with data. So in summary, data science is a vast subject. It's huge. You can get eaten up by how much you can do in it. And I think as a kind of data scientist, I think knowing what you do and what what you want to do is really kind of key, because you could spend all your time trying to learn every single thing and essentially master none of it. And so based on that, I think that need of good fundamentals is key. And, whether that be the fundamentals in Python or the fundamentals in a concept within data science you're working on, understanding is so crucial in terms of knowing how things work before you use it. Because data science now, it's such a big part of business and what we do, and the world. We've just come through a global pandemic where data has been such a key element of that, and the reporting of that back. And so actually data science and the role of data scientists, I think, is more important than it's ever been. So that need for good fundamentals is really key. Now, Python is a good choice as a language for data science. Well, because I say so, but I think it generally is. I think there's a lot of things in terms of the community, what it can do, how it works, how you script in it, its popularity. I think one thing we didn't touch on is, how many people look for Python as a subject. And I'm sure any of either you budding data scientists or those already in the area will know that, Python is, a big skill that kind of employers want. And I think it's something that you can develop quite well and be good at. And just on a bit of a tangent, when it comes to that, I always think to demonstrate your skills, the best way to do it is to code in it. Find yourself a project to do. If you've never used Python before and you're looking to use it, come up with a kind of project you want to work on, write some code, put it on GitHub, do something where a potential employer can see that you're serious about this and you're learning it and you want to learn it. I wouldn't say the number of times where I've hired people because more so because of the work they do outside of their educational job, and it shows they go the extra bit and they enjoy it, because that is a really key thing. And I think, as sad as it sounds, coding is quite enjoyable. I like building things. I like writing Python code. I would do it normally even if it wasn't part of my day-to-day job. So that's a really kind of key thing when it comes your choice of language, and I think Python's good. And the packages that we've covered, Numpy, Pandas, Matplotlib, Seaborne, they're key for data science. They're really good fundamental packages, and then they link well into other things Python does. And so having a good grasp of that is going to be really important when you're looking to develop as a data scientist, a programmer, and you're looking to be able to do things. And I think that's, again, another point. As a data scientist, you're expected to be able to do things, be given data and work with it. And so if someone gives you data and a task, you should have the skills to go away and do that. And understanding how a lot of these packages work is going to give you that kind of skill set and the confidence to go away and do it. And these libraries play well with other libraries, if we think in terms of cloud hosting, if we just think in terms of usability, there's a lot of positives around it, a lot of positives around the language of Python. I think that kind of means this is a really good choice for you as a data scientist, whether you're trying to build a CI/CD pipeline to deploy a model into AWS, or you're just looking at something to use some new machine learning package that's out there. Python's good at a lot of things, and it's embraced well. And I think, as a language for data science, it's a really kind of key thing that you can use. So I hope what people take from this is that there are a lot of good things in Python that you can use, and really just go out and explore those and kind of see how you get on with it. But I hope that people kind of understand the need for good fundamentals, learning it, really understanding it, because that will keep you in good stead going forwards. And that's really all I wanted to cover today. So thank you very much for your time, and hopefully you've enjoyed this.